microstructures. So this is the third one, that is Liga process. Basically, we have discussed that things like bulk manufacturing, micro machining, all these involve the production of the microelectronics or like microstructure for the purpose of micro fabrication purpose only. And we have also discussed about the drawbacks like low geometric aspect we have with the bulk manufacturing and surface micro machining, and these both are usually based on the silicon based materials. So in order to overcome these drawbacks, the another process comes, that is Liga process. Liga, or we have also limitation with the thickness of the silicon based substrate. In this method we don't have any these types of limitations. And we are able to produce, or we are able to fabricate non-silicon based microstructure also. As per the requirement, we are able to produce thick microstructure also. So the term Liga we have discussed, like it is a German term, that is lithography, electroforming, and the molding. And it came first in the nuclear research plant at Germany. So the Liga process starts with we have discussed that the major difference in Liga process and that we can able to produce microstructure that has high aspect ratio. So there is no restriction in using silicon and silicon compounds as a substrate, and the most commonly used material is the nickel for the Liga process. It is easier to produce in large volumes. Major disadvantage of Liga process is the requirement of special facility, that is the synchrotron radiation, that is the X-ray, that is the source of the X-ray. So this process, these are the steps of the process that starts with the deep X-ray lithography. So the process begins with this X-ray lithography that sets the desired patterns on a thick film of photoresist. So this X-ray set the desired pattern of a thick film photoresist, and the X-ray used as the light source is the photolithography because of their short wavelength. As we have discussed, when the requirement is high light, we need some high resolution for the structure, and we need high aspect ratio. Then we need in the lithography, then we need a X-ray as a source of the light or as a source of energy because of their short wavelength, which provides high penetration power into the photoresist material. So the short wavelength X-ray allows us a line width of around 0.2 micrometer and an aspect ratio of more than 100:1. So the X-ray used in this process are provided by the synchrotron radiation source, which allows the high flux of collimated rays, shortened the exposure time, that shortens the exposure times. So we can say that in this process we are getting the high X-ray. For the first start with the deep X-ray lithography, and then the next step is the photoresist with the desired pattern using a mask made up of quartz with gold plating. So here masks are used in this X-ray lithography, and the most masking material are transparent to X-rays. So it is necessary, we are using in this, that what we are using a thin film of gold to that area so that it will block X-ray transmission. So the thin film used for this purpose is the silicon nitride with a thickness of the mask used in this purpose. It is a silicon nitride with a thickness of that vary from 1 to 1.5 micrometer, and above that we use what we apply. We are applying a thin film of gold because the most of the masks are transparent to X-rays. So the deep X-ray lithography will cause the exposed area to be dissolved in the subsequent development of the resist material. So PMM photoresist after the development will have side profile of the tube. This is followed by the, or we can say that, or you can see here in this process, we are fabricating a microstructure. That is the metal tubes of a square cross section, and here they are discussed in the process. It is begins with on the surface of the substrate as shown in the figure A. That is then we are placing a thin film of gold over it. After the photolithograph, just after the photolithography. So then we are depositing, or we can say that photoresist, the desired metal. Usually here they use desired material is the, yes.
सर आपका बीच में आवाज गायब हो गया बोल रहे
Okay, maybe some network issue. Hello.
Yes, sir.
Is it fine?
Yes, sir.
Okay. So we are producing a micro thin wall metallic tube of a square cross section. This is the example to understand the Liga process. Okay. So the first step is to develop or depositing a thick film of photoresist material on the surface of a substrate, as shown in the figure. And after that, we will deposit a thin film of gold over that, and then we will do the deep X-ray lithography, and that will cause the exposed area to be dissolved. And after that, this step is, that is the second step, is followed by the electroplating of the PMM photoresist with the desired metal. And the most common desired metal is what? That is the nickel. So the desired product is, after that, to produce the tubular product of the required thickness. The desired tubular product is produced after the removal of photoresist material, that is the PMM in this case, by the oxygen plasma or chemical solvent. So at the end, metal plating could also be used as a substrate. So what with the photoresist material? What about what are the features of photoresist materials, or what is the requirement of photoresist material for the Liga process? It must be sensitive to X-ray radiation. It must have high resolution as well as high resistance to dry and wet etching. And it must have thermal stability up to 140 degrees Celsius. The exposed resist must be absolutely insoluble during the development. and it must exhibit very good adhesion to the substrate during electroplating. If it not exhibit the adhesion, then there is no possibility of electroplating. So based on this requirement, what we have found, that PMM is the most desirable or most considerable photoresist material for the liga process. At the present time, we can say that. So if we compare these tables, like on the basis of different parameters like sensitivity, resolution, sidewall smoothness, and the stress concentration. But we are saying that like material like PMM, PUM, polyoxymethylene, like PS, polyalkaline sulfur, and PMI, polymethyl acrylamide, and PLG, that is poly. PLG is only poly, that is the lactic co-glycol. So these are the things, these are the different types of photoresist materials. So on the basis of sensitivity, resolution, we can compare that what is our need. If the sensitivity is not of much concern, or we need high resolution and high sidewall smoothness, so we can go for the PM. If we need like sensitivity is high, as in the last column, that is the PLG, that everything is high, like sensitivity is reasonable, and the resolution is excellent, the smoothness, or we can say that sidewall smoothness is excellent, and the stress concentration is also excellent. So we can go for this, but it depends on the various parameters, like what is the requirement and how much money we want to spend on the particular product. So as per the requirement, we will go with the different types of photoresist materials. For the requirement, we will go with the different types of photoresist. This is some limited material. In the present, there may be or there are different types of materials for the liga process. There are different types of materials for the liga process. So there is the electroplating term in the liga process. So we will discuss what is electroplating and how we are going to form the electroplate on the photoresist material. So electroplating is the most important steps in the liga process. On the photoresist material. So electroforming of metal films onto the surface of the cavities in the photoresist after axial lithotripsylation performed. So nickel is used as a metal to be electroplated on the photoresist material. So nickel is photoresist wall, sidewalls. Other materials also can be used, but nickel is the most common material. Other materials also can be used, but nickel is the most common material. So you can see that in the figure there is a conductive substrate and there is a carrying photoresist structure from the cathode in the electroplating process. Like in the electroplating works on the principle of that, like here is a chemical reaction, like nickel ions from the nickel chloride solution reacts with the electrons at the cathode to yield the nickel. In this way we are forming a nickel plating. That is, we are getting the nickel ions from the solution and the electrons at the cathode that will yield the nickel. From the solution and the electrons at the cathode that will yield the nickel. So there is, if we are getting the ions like electrodes, so there should be a presence of hydrogen also, and that will cause hydrogen ion, or that is, you can say that hydrogen causes the unevenness or uniform surface of anion. So we have to take care H2 gas is the product of H2 ions plus we are getting in the electrolysis solution. So we have to take care of this also, that hydrogen. To avoid the we have to take care of this also, that plated surface of by the hydrogen bubbles. We need to control the pH, the temperature, and the current density in the electrolysis process. So means we are producing nickel plating, and there is ununiformness or non-uniformness, we can say that, because of the hydrogen gas in the solution, or electrolysis process produces hydrogen. So we need to take care by what? We are just controlling the pH of the solution and the temperature and the current density in the electrolysis process. These things will control the formation of hydrogen, and so that we are able to minimize the non-uniform anion plating.
These things will control the
So this is about the
hydrogen and
Liga process.
so that we are able to minimize
So
the
we have
non-uniform
discussed three types of process. Like first one is
So this
bulk
is about
manufacturing,
the
the
Liga
second
process.
is micro machining, and third one is
So we
Liga
have
process.
discussed three types of process.
So
Like first one is
this is the summary. What is the difference between
second one is
different
micro
types of
machining and
process?
third one is Liga
As we have
process.
discussed, like bulk
So
manufacturing, this is the less
this is the
expensive,
summary. What is the
but
difference
material
between
loss is high.
different types of process? As we have
If we
discussed,
discuss
like
about
bulk
the
manufacturing, this is the less expensive,
microstructure, it is
but
suitable
material
with
loss is
the
high.
simple geometry. Complex is not
If we
possible
discuss
with the
about the
bulk manufacturing. So, and
microstructure,
the
it is
aspect
suitable
ratio,
with
we can
the
say that about aspect
simple
ratio. What is
geometry.
aspect
Complex is
ratio?
not possible
The
with the
ratio
bulk
of
manufacturing. So, and the
minimum.
aspect ratio, we can say that about aspect ratio. What is
aspect ratio?
The ratio of
So it's the ratio of image to the width.
anyone? Ratio between width and height. What is
Okay.
aspect ratio?
Means we can say that what is the whatever the measured dimension, either the measure means that have the maximum value. If the
So we can say that
length
what
of
is
the surface is high,
the
then
major
the,
dimension.
that is the major
Either the
dimension to the minor
measure means
dimension.
that
Can say
have
that
the
the thickness
maximum
is
value if
minor, less
The
as compared to
length
the
of the surface
length.
is high,
So
then
that is the
that is
ratio
the
of the
major
measure to
dimension
the
to the
minor.
minor dimension. Can say that the thickness
So
is
that
minor,
in most of the
less
cases you are
as
seeing that
compared
100
to
is to
the
1, 200 is to 1.
So the,
That means
it's
the length,
ratio of
if
the
your
measure to the
the
minor.
length is the measured dimension, then the length is
So that
about
in most of
200
the cases you are
and the
saying that
thickness is
100 is
1
to 1, 200 is to 1.
micrometer in that case.
That means
So
the
this is the
length,
ratio.
if your
That is
the
aspect
length is the
ratio,
measured
and
dimension, then
in
the
the bulk
length is
manufacturing,
about 200
it is limited to
and the
low
thickness
aspect
is
ratio.
1
We are not able to
micrometer
produce
in that
high
case.
aspect
So this
ratio.
is the
Means
ratio.
if the length
This is
is
aspect
increasing,
ratio,
then we have to
in
increase
the
the.
bulk
This means that
manufacturing, it
low
is
aspect
limited
ratio
to
means
low
if we
aspect
are
ratio.
increasing
We
the
are not
length
able
of the
to produce high
microstructure, then we
aspect
have to
ratio. Means
increase the
if the
thickness
length
also
is increasing, then we have
comparatively.
to increase the. This
So
means
it is
that
limited to
low
this one.
aspect
So
ratio
the
means
but
if
surface
we are
micro
increasing
machining
the length
requires
of
a
the
layers of
microstructure, then we have
materials
to
over the
increase the
substrate as we
thickness
have
also
discussed, and we are able
comparatively.
to produce the
So
complex
it is
masking
limited to this one. So the but surface
design and
micro machining
production.
requires a layers of
So
materials over the
etching of the
substrate as we have
sacrificial layer
discussed.
is
Then we
necessary
are
here
able
in
to
this
produce
case.
the complex masking design and production. So etching of the sacrificial layer
So the
is
process is
necessary here in
tedious
this
and more
place.
expensive. There are serious engineering problems like interfacial stresses and restriction.
So the process is
And addition of the
and more
layer, we have
expensive.
discussed these things. The major advantage
There are
is not
serious
constrained by
engineering
the
problems
thickness
like
of the silicon
interfacial
wafer.
stresses and
Wide
restrictions.
choice of thin film
And addition
material
of
to
the
be
layer,
used.
we
You
have
can use
discussed
in
these
this
things. The major
different types of thin
advantage is
film
not
materials
constrained
suitable
by
for
the
complex
thickness of the
geometry
silicon
such as
wafer.
micro
Wide
valves and
choice of
actuators can be
thin
formed
film
using this micro
material to be
machining
used, it
techniques.
can be used in this
And the Liga
different types of
process is,
thin film
we have
materials
discussed
suitable
that
for
it is
complex
most
geometry such as
expensive with
micro
the initial
valves
cost,
and actuators can be
and
formed using
requires
this micro
for
machining
the deep
technique.
X-ray is what? The special
And the Liga process
synchrotron
is, we have
radiation
discussed
facility
that
we
it is the
required for the
most
deep X-ray
expensive with
lithography,
the initial cost,
and micro injection
and
molding
requires
technology and
for
facilities
the
for
deep
the
X-ray is what?
mass
The
production
special
is can be
synchrotron
possible with the Liga
radiation
process.
facility we required for the
So
deep
the
X-ray
measured
lithography.
advantage is
And
virtually
micro
unlimited
injection molding
aspect ratio.
technology and
What does
facilities
this
for
mean?
the mass production
Unlimited
is,
aspect ratio.
can be possible with the Liga process. So the measured
So without
advantage is
You can
virtually
increase the length
unlimited
without
aspect ratio.
having to
What does
change the
this mean?
thickness.
Unlimited aspect ratio.
virtually unlimited means we can we are increasing virtually unlimited means what? If the upper, if you are, that is infinite. If you are getting some ratio is infinite means
Virtually unlimited
the
means
denominator is what? About
we
to
are increasing virtually unlimited means what?
So this is the word is virtually
If you are
unlimited aspect
infinite,
ratio.
if you are getting some
It's
ratio is
about to
infinite
zero
means
with the increasing of the length.
denominator is what? About to
So
zero.
the flexible
So
in
this is
microstructure
the
and
word is
configuration.
virtually unlimited aspect
This
ratio.
process is flexible with the
It's about to
microstructure
zero
configuration and
with the
geometry.
increasing of the length.
So the only techniques allow the production
So
of
the
metallic
flexible
microstructure. We can
in
say that.
microstructure and configuration, this process is
So
flexible
this is
with the
about the different
microstructure
types of micro
configuration and
manufacturing
geometry.
techniques.
So the only techniques allow the production
Now
of
we'll go
metallic
with the
microstructure. We can
applications
say that.
why we are forming or why we are using micro
So this is about the
fabrication
different
methods
types of micro
for the
manufacturing
purpose
techniques.
of the what? For the purpose of
Now
fabrication
we'll
of
go with
MEMS
the
and microsystems in
applications why we
automotive
are
industry.
forming
So this
or
is
why we are
what
using
is the
micro
example around
fabrication methods for the purpose of the
You can say that if we are
for the
increasing
purpose of
day by day,
application
the
of MEMS and
automotive sector
microsystems
are
in
increasing. So
automotive
what is the
industry.
need? We have to
This is
increase the
what is the example around.
safety, engine power. Like we have to monitor
We
these
can
things.
say
Sir.
that if we
There
are
are very much
increasing day by
requirements
day,
of
the
MEMS in the
automotive sector
automotive
are
industry. As
increasing.
with the
So what is the
and
need?
day
We
by
have
day
to
it
increase
is
the
increasing.
safety,
To
engine
somewhat
power.
we can say
Like we have
that to increase the
monitor these
facility,
things, sir.
or
There
we
are
can
very
say
much
that to increase
requirements
the
of MEMS
safety.
in the automotive industry, as with the and day by day it is increasing.
To add some luxury in the
Somewhat we can say
automotive
that
industry,
to
they are
increase the
increasing day by
facility,
day.
or
So the
we can say
application of
that to
MEMS is
increase the
also increasing.
safety.
So what type of different types of principal sensors used in an automotive
To add some luxury in the automotive
industry, you can
they
say
are
that different
increasing
types
day
of
by day.
sensor.
So
Like first one,
the
we can say that
application of MEMS is also
the
increasing. So what type of different
manifold or
types of
temperature
principal
manifold absolute
sensors used
pressure
in
we need to
in
measure.
automotive
Then the exhaust gas differential pressure, this type
industry?
of
You can
different
say
types of
that different
sensors
types of
we are
sensor. Like
using
first
in the
one, we can say that the
automobiles most of the
manifold or
times.
temperature manifold absolute
So
pressure we
most
need
of
to
the time
measure.
they are in the
Then
size
the
of these
exhaust gas
sensors are very
differential
small,
pressure. This type of different
and
types
they
of
are
sensors we are
fabricated with
using
the help
in
of
the
microfabrication techniques like fuel
automobiles
rail,
most of the times.
pressure sensor,
So
tire
most
sensor,
of the time
transmission
they are
sensors,
in
fuel
the
tank
size of
evaporative
these
oil,
sensors are
fuel
very
pressure
small,
sensors, engine oil
and they are
sensors,
fabricated with the help
gasoline
of
direct injection
microfabrication
pressures.
techniques.
All we need to
Like
monitor what
fuel
is
rail,
happening with these things, so that we will
pressure
able to
sensor, tire
control
sensor, transmission
everything
sensors, fuel tank
from
evaporating
a
oil,
button
fuel
or
pressure
from a
sensors,
remote also.
engine oil sensors, gasoline direct injection
So
pressures. All
silicon
we need to monitor
capacitive
what is
manifold
happening
absolute
with these
sensor
things,
pressure, like
so
this
that
is
we will able to control
the structure of
everything
this silicon
from a button
capacitive
or
manifold
from a
absolute
remote
pressure
also.
sensor. So I'm just showing you the
So
different types of
silicon
applications.
capacitive manifold absolute sensor pressure.
Then,
Like
So what is
this
the
is
meaning of manifold?
the structure of this
have you learned
silicon
about IC engine?
capacitive manifold absolute pressure sensor.
No, sir.
So I'm just showing you the different types of
So
applications.
there is a manifold provided in the IC engine that will
Then,
So what is
control
the
the,
meaning of manifold?
we can say that
have you learned about IC engine?
the mixture, air fuel mixture issue sometime.
So there is a manifold provided
So
in the IC engine
applications
that
of
will
MEMS and
control
macro structure
we can say that
in the aerospace
the mixture,
industry. You
air
can say
fuel
that in the
mixture
aerospace
issue
industry. So there are different types of sensors, like as we have discussed in the automobiles.
So applications of MEMS and microstructure in the aerospace industry. You can say that in the aerospace industry, so there are different types of sensors, like as we have discussed in the automobiles. So
You're not audible.
Just someone is message. I am just let someone has messaged in the chat. Okay. So these are the applications with the aerospace industry, like
just
wind tunnel instrumentation. There are lots of automation in the aerospace, in automobile, and we require MEMS and microsystem for all these things. There are a number of applications you can go through it. There is no need to read these things. I will
wind
send you
tunnel
the
instrumentation. There are lots of automation and in the aerospace, in automobile.
So this is the application of MEMS in the biomedical industry. Like we need this MEMS many times for the precision. We can to get precision for the like kidney dialysis equipment, medical purpose monitoring, barometric
this is the application of MEMS
correction instruments. Sometimes we need some MEMS or like microstructure for the precision surgery also nowadays.
Precision for the like kidney dialysis equipment,
Microbiome analytic scheme and biochips and capillary electrophoresis. These are the different types of applications in the biomedical industry.
Surgery also nowadays.
So these are the just name of some limited applications.
Microbiome analytic scheme and biochips and
you can say that in the consumer industry or day-to-day life, the scuba diving watches and computers we need, the bicycle computers, like sensors for fitness gears, washers with water level controls. So these are the different types of MEMS that we are using in the day-to-day life. We can say that this is the consumer products, the sports shoe with automatic
bicycle
cushioning
computers
control,
like
digital
sensor
tire
for fitness
pressure gauge,
gears,
vacuum cleaning with
washers
automatic
with water level
adjustment of brush
controls.
bitters,
So these are
smart
the different
toys.
types of
So
MEMS
these are the
that we are
day-to-day life
using in
products.
the
It is a
day-to-day
consumer
life. We can say
industry.
that this is the consumer products. So the sports shoe with automatic
So this is
cushioning
the
control,
MEMS for the
digital tire,
telecommunication industry.
pressure
Like
gauge,
what is the application?
vacuum
Application
cleaning
is
with
to optical
automatic
switching and
adjustment
fiber
of
optic
brush
couplings,
bitters, smart toys.
RF
These are the
relays,
day-to-day life
switches,
products
and
in the
tunable
consumer industry.
resonators. These are the different types of industry. If you go with each and every
So this
application,
is the
you find
MEMS for the
another level of research in this
telecommunication industry.
everything.
Like what is the application? Application is to optical switching and fiber optic
So this is
couplings,
about all the applications
RF,
of the
relays,
micro
switches, and tunable
fabrication techniques for
resonators.
the
These are the
purpose of
different
the
types of
production of
industry. If you go with
MEMS and
each and every
microsystems.
application, you find another level of research on this
Mhm.
everything.
So
So this
we
is
will
about
just
all the
stop
applications of
here.
the micro fabrication techniques for the purpose of the production.